Alright folks, today we're going to cover a couple different sections here. First up is talking about scale changes to an entire data set. We've been working with scale changes for points and for equations, but now we're going to look at an entire set and see what happens. So you'll notice this rule looks a little different. Instead of s of xy, okay, we're only dealing with one variable here, so we only care about the one multiplier instead of one for each variable. What we're going to do is look at some examples to see what happens. We did the same type of thing during 3-3, looking at how translation affects the sets. Okay, so we're doing that for this first example. It says, as a fundraiser, club members are selling candy for $2.50 per box. The number of boxes of the 17 members who sold the candy are given in this list. So that's 27 boxes, 30 boxes, and so on. Our job is to find the original statistics for this set so that we can see what scaling it by our money actually does for us. So, what I want you to do is pause the video and put all of these numbers for me in list 1 so that we can find some of these stats. Once you've got it typed in, if you remember, we're going to hit Stat, over to Calculate, and one variable statistics to go get those things. So make sure it's on list 1, but then you can go ahead and calculate it. We've got a little bit of ugly numbers here, but that's okay. Sometimes things don't work out nice in real life. We're just going to say when we round, and we'll just round to 2 decimal places. Okay, so the first up, mean, it says, is about 37.76. Now remember, this is all dealing with this first set, which is number of boxes. So up here I'm just going to write boxes to take care of those labels for me. Now we can't really have a partial box, but this is just an average, so it's okay, it looks a little ugly. We'll scroll down to find the median, and it's 38. Remember, mode isn't in our calculator, we just see it from our original. We're looking for the most frequently occurring number. Okay, so it looks like we've got double of a few here, 32, 35, 41, and 44. That means we have multiple modes. We just list them all. Now, if every single number appears 2 times, we're not going to say there are multiple modes for that. There would be no mode. So we've got 32, 35, 41, and 44 there. Range is max minus min. We're lucky here, it's in order, so we don't really have to look at our calculator. Max and min. We're going to subtract those to get T3. IQR, we need to look at our calculator so that we can take our Q3 minus Q1 directly from there. So that looks like 42 minus 33 for us, so 9 boxes. Standard deviation, remember we want to use the sample unless we're directed to use the population. So we'll go up to the SX, not the sigma X. So that's about 5.89. And hopefully you remember variance is just that squared. We want to use the exact number. That is one of the nice things about variance. It's always rational. If you remember from that formula, the square root goes away. So to get our exact number, those, remember, are stored in bars. So we'll hit that. We're talking about statistics, so number 5. And then it's right there, number 3. But then we want to square that thing to get our variance. Now, right now, that doesn't look very exact, and in this case, a decimal is fine in order to figure out what we're doing, but it really should be a fraction. If we do math enter, it can write it as 1. Again, I'm okay with rounding because we're just trying to see the pattern here to see what's happening from the original to the scale data. So I'm just going to round this one as well, 34.69. But what's different about this one is we're saying boxes times boxes, so this one we have to say boxes squared on. Doesn't match our other label. So now what we're going to do here is talk about the scaled data and what happens to all of these statistics when we think about the money being applied here. So the scaled number we're multiplying by here is 2.5 because we're talking about the price of all of the boxes, so essentially the number of dollars earned for each member. So in our calculator, let's all go back to the list, and what we're going to do is in list 2, we're going to multiply everything by 2.5, and remember, we don't have to do that by hand. Our calculator will do it for us. We just have to take list 1, so get up to the title of list 2, make sure that's highlighted, and then hit second 1, and we want to multiply by 250. That'll fill that in for us. And now we'll calculate the statistics for the money. So, with this in mind, let's go to our stat, calculate. We're still having one variable, but now it's in list 2. So we'll have to hit second 2 to change that. What I want you to do is pause the video and get these numbers written down for me. Again, it's okay to round to 2 decimals. Alright, so we've got our numbers here. They're talking about money since we have this boxes times price situation. If you go pay for that, it's in money. I want to talk about a couple things here. The first one being the mode. Remember, mode is the most frequent. You just go to your list. Since we don't have those written out, you'll just have to go back to Stat, Edit, so you can see your list again to go find those most frequent. Second thing I wanted to talk about, remember, for the variance, you have to make sure that you're using the exact version. So use VARS to get that standard deviation exactly and then square it. But once again, it's okay to look at the decimal because we want to do here is see what's happening. We learned last time when we were talking about transforming a set of numbers that sometimes things change, but sometimes they didn't with translations. Well, you'll notice with a scale change, every single one of them changed. Okay, but what we want to figure out is by what. So the first one here, okay, we're multiplying by 250 to get this. So hopefully you're getting this idea of, well, maybe it just changes by a factor of 250. Okay, what we're going to do is test that for each of these. Okay, so remember, since we've rounded, it won't be perfect, but if we think about the first one, if I want to know that if I'm multiplying by 250, okay, I can go backwards or forwards. I'm just going to divide that and see if that's happening. Okay, it's pretty dang close. Another way to decide is literally just take your 2 numbers you have, divide them, and see about what number you come out to. Okay, so that's 94.41, and we divide that by the 37.76. Very close to 250, and that's good for us. Okay, so our scale factor really is that 250. That was our money for our price of our candy. Okay, let's check out the next one. See if it's also 250 like we want it to be. It is. That's good. These ones, we don't have to check all of them individually. Just one is fine. 80 divided by 32. That's 2.5, so that works for us as well. So it's looking like they're just multiplying by 2.5. Okay, this one still 2.5 times. This next one, if you think about doubling it and a little more, 2.5. Here, 2.5. The problem is this one. Okay, so I'm going to go ahead and type this one in so we can see it. 216 is more than 2 times 34. Okay, so we need to figure out by what times is actually happening. So this is 216.82, and I'm going to divide it by 34.69. And we're getting to 6.25 again. Right? So to kind of help us with this, I want you to ignore decimals. So instead of thinking this as 25, or as 2.5, let's think of it as 25. Same thing here, instead of thinking as this 6.25, let's call it 625. Okay, and how do those compare? Okay, I'm hoping that you see in terms of perfect squares what's actually happening. Here's the big idea. When we think about variance, we know we're taking the standard deviation squared. We just decided that the standard deviation got a multiplier of 2.5. So that means when I go and take my variance, I've got 2.5, sorry, let me rewrite that, 2.5 times whatever this is, but then I have to square it, which means the 2.5 gets squared as well. Which is equal to that 6.25. So all of them got multiplied by the scale factor of 2.5 except for the variance, which actually got it done twice. All right. Well, just like what we did with translations, we want to make sure that that happens when a negative scale factor is used as well. Okay. Please don't assume this does the same thing. It's actually a little bit different this time, whereas translation wasn't. Okay, so what we're going to do here is type these in a list. There's not even context. We just want to see the pattern. Okay, so pause the video real quick and type in the first list so that we can get the original statistics. Alright, once they're in and double checked, we're going to calculate the variable statistics. I cleared everything out and put it in my list 1. So we'll change this back to list 1. And then here are my statistics. Okay, so we're going to fill this out. First up, the mean is 29. We don't have any context here, so it's just a set of numbers. We don't have to worry about labels. Then we're going to the median, 28.5. Mode, we look up at our list and decide if there's a number that appears more than once. Looks like that's not happening for us, so we don't have one. The range, we want to go ahead and take, remember, the maximum minus the minimum. These aren't organized, so you may want to go to your original. So we're looking at 19 and 42. That way you're making sure you're getting the lowest and the highest. Okay, so from 19 to 42, we've got a distance of 23. Alright, now we're doing the same thing, but the IQR, okay, so with this we want to take Q3 minus Q1, and that looks like a distance of 7. Standard deviation is your SX. It may be a little bit ugly, let's go see. Okay, here we're going to round to 2 decimal places again, 6.87. And finally, we'll just go square that. Again, let's use VARS. It grabs all the decimal places so we don't have any rounding error. VARS statistics, standard deviation is that third one. And then we'll square it for about 47.14. This time what we're going to do is multiply by -3 and see if everything in our new scaled data statistics actually gets multiplied by that -3 or if something different's happening. So go to your list, and in list 2 we're going to type in list 1 times -3. Remember, make sure you're up in list 2 so that it says L2 equals, otherwise you'll have issues. And then we'll calculate those statistics. Okay, everything's going negative here because we start out with a positive list. Okay, let's check what our statistics do. So, calculate one variable statistics, change it to list 2, and take a look. Okay, what I want you to do is pause the video and write down all of those statistics for me. If you can, see if you can notice the pattern this time that's different than last time. What are we multiplying each one by? And we'll come back to talk about them. before we talk about the pattern, I want to have you pay close attention to these ones where we had to subtract the range and the IQR. If we think about the maximum minus the minimum, okay, the maximum here was a negative, so was the minimum, but I'm taking a negative 57 minus a negative 125, which actually makes it addition. Okay, that's why I have a positive range here. IQR, same thing. I have Q3, which is negative, but I'm subtracting a negative to give me that positive 21. Okay. So when we go through here, the first one, it really is multiplying by negative 3. Same thing with the next one. But here, it's not a negative 3, we're actually just multiplying by 3. Same thing with the IQR, same thing with standard deviation. Okay, but variance is not multiplied by 3, just like the last one, okay, to show you kind of an idea of what the number is, because it's not as obvious what you're multiplying by. Type it in. Take your 424.29 and divide it by 47.14. Again, we're going to have some rounding error here because we rounded, but it's really close to 9. So what's happening is these things, the mean, median, mode, we can't tell here because we didn't have one, but they're being multiplied by whatever A was. But these ones, the negative didn't come through because we're talking about a distance measure against spread. Okay, spread and distance are not negative measures, so we're really multiplying by the absolute value of A. Variance, absolute value of A still, but squared. So what we're going to do here is make a note card to generalize this. If you want, you can just put this on the back of your 3-3 where we generalized what translations do. Okay, but call this one 3.6. It says if each element of a data set is multiplied by a scale factor A, then the original mean, median, mode are going to go to A times that, just multiplied by A. And again, if you want to shortcut that, you can just say times A once. But then our measures of spread are going to get multiplied by the absolute value of A. We didn't see that in the first example because we were already multiplying by a positive A value. And then the last one is A squared. Now we know that when you take a negative and square it's also positive, but I still like having this absolute value bar marked on there just so we know that really any measure of spread we want to think positive since it's a distance measure. Okay, so pause the video, make sure you get that written down, and then we'll talk about the 3-7 stuff. 3-7 is just review of composition. Okay, you should have done this in Algebra 2, so it's just a little bit of a refresher here. When we see this open dot, it really means the word following. Okay, so this is F following G, which means G gets to go first. So what we're going to do is find this first. And this says G of -2. So we're going to go to the G function, and instead of seeing an X here, we see -2. So we're putting a -2 in the place on that side. So it looks like -2 minus 7, which is -9. Now what we just said is this whole thing is -9. So now we do F of what's left, that -9. So now we're looking at the F function, and instead of X we have -9, so everywhere we see an X we put -9. So 2 times -9 squared plus 3 times -9. Alright, we have to simplify this. When we plug in a number, we have a single number here. So this is 2 times 81. Over here, it's minus 27. Okay, so you can just type that in there. To get 135. So we'll write this like we saw it. I actually don't like this version very much. I don't add in extra parentheses. I'll just say F following G of -2 equals that 135. And that's the final answer. Alright, over here, we've switched the order. This says G following F, so F goes first. We're doing F of -2 to start out with. So in your function, we're going to F first and plugging in -2 everywhere we see an X. And simplifying. You can technically type this thing in immediately in your calculator. I just try to avoid a bunch of parentheses if I can. So here, -2 squared is 4. 3 times -2 is 6. So we've got 8 minus 6, which is 2. We're saying all of this is 2, so now I'm left with G of 2. Basically, whatever number you take, or you end up with, you take and put in the outside function here. So now we're looking at the G function. It just says x minus 7, so that'll look like 2 minus 7 for us, which ends us up with a -5. Rewrite it. G following F of -2 equals -5. And we're done. Next problem is only different because we're dealing with a function instead of a number. Okay, so our process is actually a little bit easier because I still start with G of X, but since I'm not plugging in a different number, I already have G of X right there. Okay, so what I'm going to do is take that and put it into F. So this whole thing goes in to the function, again, everywhere I see an X. So we'll start out with just writing in grouping symbols 2 times this x minus 7 squared, then plus 3 times x minus 7. Now, we only have one step here, but we will have to simplify, which usually requires a little bit more work when we're dealing with functions versus just regular numbers. So, when I say squared, remember that means it's really happening twice. So, I'm just going to go ahead and rewrite it twice, but then bring down this rest here. Leave the 2 alone and go ahead and FOIL this thing. What I want you to do is combine like terms as you go. If you know the shortcut for squaring a binomial, use it. Okay, but we're taking x times x is x squared. When I say combine like terms, the middle 2 are going to be combined here. We've got minus 7 minus 7, so that's minus 14x, and finally a plus 49. Okay. Now what we're going to do is go ahead and distribute these things through so that we can combine like terms. So we've got 2x squared minus 28x plus 98. Then we've got plus 3x and minus 21. So, all the way through here, okay, you don't have to write this f of g of x every single time, but you do have to write it when you're done. Okay, so if you need to write it on every step so you don't forget it, please do that. But we can go ahead and simplify. There's only one squared term, so you only have to write that once. That's gone. Then we're going to combine these ones. We've got negative 28 and positive 3, so negative 25x. Those are done. And then we're taking 98 and subtracting 21, so that's a positive 77. And that will be our final answer. Okay. The next one's a little bit easier, going the other direction. I'd like you to pause the video and try that one for me. This time we're taking this and subbing it in. The reason this one's easier is because we don't have to actually simplify very much here. Okay, it says x minus 7. This thing goes in for our x. So we see 2x squared plus 3x and then minus 7 on the end. But these parentheses, since we're not multiplying anything through them, don't really mean anything. We don't need them there. So our final answer is just that substituted in 2x squared plus 3x minus 7 and we're done. Okay? If you have any questions on that or any of those scale change problems on your homework, please come see me.